Hi all, welcome to new class. Today's class is about filters. So in the previous classes we have discussed about rectifiers, and the rectifier output contains AC component and DC component, and the AC component present in the output of rectifier is called ripples. And this ripple is responsible for the pulsations in the wave. Hence, the output of a rectifier has to be smoothened. So, the process of removing or minimizing the ripples in the rectifier output is known as filtering. And a circuit which removes the ripples in the rectifier output without affecting the DC component is called filter. Let us study about a shunt capacitor filter and series inductor filter. First one is shunt capacitor filter. This is the simplest filter circuit with a high value capacitor connected across the load resistor. The capacitance offers low reactance to the AC and high reactance to DC. A small ripple voltage will be available at the output. And the capacitor has the property of storing the charge for more time. When the rectifier output voltage increases, the capacitor charges to its peak value. And when rectifier output voltage falls, the capacitor discharges slowly through the load. So during the positive half cycle, the capacitor charges, and during the negative half cycle, it will be discharging through the load. Though the rectifier output voltage decreases, capacitor voltage will not follow it. When the rectifier output rises, that is again this one will be conducting, capacitor charges to its peak again. That is during the negative half cycle, capacitor charges again in this way, and that is this one. So this is discharging period. So capacitor charges at this point again, and the cycle repeats, and thus fast varying rectifier output voltage gets smoothed to low rippled voltage. Next is series inductor filter. An inductor has the fundamental property of opposing any change in current flowing through it, and this property is used in the series inductor filter, and this is the circuit diagram. And whenever the current through the inductor tends to change, a back EMF is induced in the inductor, and this induced back EMF prevents the current from changing its value, and any sudden change in current that might have occurred in the circuit without an inductor is smoothed by the presence of the inductor. And since the reactance of the inductor increases with frequency, better filtering of the higher harmonic ripples take place. And this is the waveforms. So that is about the filters. So thank you for watching the class. If you like the classes, please like, share and subscribe my channel.